Example 3. We are given a side and a corresponding angle, angle A and side A. We will solve for angle B because we know side B. Setting up the law of sines, we have the sine of angle A over side A, which is the sine of angle B over side B. To get sine of B alone, we will cross multiply and divide. Sine of B equals 8 multiplied by the sine of 35 degrees divided by 6. To get B alone, we will need to undo sine. So we will apply inverse sine to both sides. But you may want to first use your calculator to find the decimal equivalent of the right side. Now inverse sining both sides, the inverse sine of B is B, and the inverse sine of 0.7647686 is about 49.9 degrees. Okay, so danger. Remember, when you use the law of sines, and the first thing you do is find an angle, then you must check for a second triangle. It is possible with this given information that there are two possible triangles. To check, what you want to do every single time is to take 180 degrees and subtract the first angle you found. That's going to give you the possible alternate angle. In this case, it's about 130 degrees. One more time. If you are given a side and a corresponding angle, and the first thing you do is solve for an angle, you may have a second triangle. As soon as you've found the answer to the first angle, you immediately subtract that amount from 180 degrees. And in this case, the angle is B prime. If we would have first found angle A, then we would have had A prime. Whatever angle you get, in this case B prime is 130 degrees, to make the decision if you have a second triangle, you take the given angle, the prime angle you found by subtracting the first angle from 180, and add them together. If this amount is less than 180 degrees, you have a second triangle. In this case, it is under 180 degrees, so we do have a second triangle. You proceed with the given information and each of these angles, angle B and angle B prime, but it's like you're doing two separate problems. I'm drawing a line down the center to emphasize that we really have two separate problems, the problem on the left and the problem on the right. In both instances, you will use the given information. To find angle C, I will use the fact that all triangles add up to 180 degrees. Substituting the given angle A and angle B, I get C alone by subtracting those angles, and C is about 95.1 degrees. Next, I can find side C. The sine of angle A over side A is equal to the sine of angle C over side C. Cross multiplying and dividing, I will find the answer to side C, which is about 10.419. It is very important that when we found angle C above, that we used as many decimal places as we could. If you round a number that you are going to reuse, your final answer will be off by even more. Okay, on to the problem on the right. We can only use the given information in angle B prime. To find angle C prime, we will use the fact that all triangles add up to 180 degrees. When we substitute the known angles, again, we can only choose from the given information and angle B prime. So we substitute angle A and angle B prime, and we will be finding C prime. Subtracting those angles over, we find the answer to angle C prime. Now that we know angle C prime, we can find side C prime. Sine of 35 degrees over 6 is going to equal the sine of angle C prime over side C prime. To find C prime, we will cross multiply and divide. And the answer to C prime is approximately 2.687. A quick recap. The given information contained a side and a corresponding angle, which told us to use law of sines. In our very first step, we found an angle measure. If you find an angle measure as your first step, then you may have two triangles. When you solve for the first angle, you then subtract it from 180 degrees. The leftover is the prime of that angle, if there is a second triangle. You can tell if there is a second triangle by taking the prime angle and adding it to the given angle, and if you are under 180 degrees, there is a second triangle. If you are 180 degrees or more, there is not a second triangle.